Hi, I'm Tim Champagne. I'm an application security engineer at Medallia. So that's me at DEF CON. This is me trying to be a little bit more presentable for y'all. So I have my likes. If you catch me down at the bar, I like porters and stouts. I'm not too keen on bios, though. So if you want to know more, I direct you back to my likes.
And hi, everyone. I'm Harshal. I'm also in the security team at Medallia. We are an enterprise SaaS company. We focus on feedback management. So make sure before you leave, you put your feedback, green or red, in that bowl up there before you go. We've been working together for quite a while, and we've spent a lot of time building a fantastic team of engineers, and we focus on a lot of both the offensive and the defensive side of security. We'll talk about one of the aspects that we're really proud about today. But before I go too far down the path, how many of you have some sort of system or control or process in place for security of open source libraries in place? Oh, that's a lot. That's awesome. That's good. So we'll have some interesting conversation. Okay, so today, Tim and I will take you through a journey of how we realized that security of open source components is something important, how we came to prioritize it, where we initially started, what we learned from our initial approach, and where we are today with our current model, which is more aligned with DevOps. I also want to take this opportunity and encourage all of you to really embrace integrations in CI pipelines if you have that at your shops. It's honestly one of the best things you can do for your AppSec program, so really think about it. We'll talk more about how we did it today. So, going back in time, when we were thinking about whether this is an area, open source library security is an area that we want to spend our time and resource and really prioritize, we kind of knew that it was an issue, but we didn't really know how bad it was, right, or how important it should be. So we started collecting some data points from within the organization. What we found out was almost every single application or a service that our engineers have written had at least one open source component in it. It's probably not very surprising. The other data point that we gathered was more than half of the code is actually coming from open source components. Right? So we're a SaaS company, we're a technology company. We have hundreds of engineers writing code every single day, and think about it, more than half of it comes from open source components. That's a lot from a volume perspective at least. The other thing that we also noticed was our monitoring systems were picking up more and more attacks and exploits that specifically targeted open source components. This is relatively new, but it just aligns well with what we are seeing in the industry, especially with struts happening and things like that. Okay, so what really makes this different than anything else in the world of AppSec? There are a lot of things bad in AppSec, but particularly for this open source components, what we observed was it's really easy for a developer to add a new library or an old library or a vulnerable version of a library and push it out to production really quickly, especially if your organization follows DevOps. It can happen really quickly. The other thing we noticed is when issues do get in code, when they reach in code, it generally takes longer to fix issues in open source components than other libraries. Obviously, you have to rely on your upstream provider to publish a fix, and then you can patch it. But what we also observed was that generally, open source components take much longer to publish those fixes, or they're just not maintained really well in the community. And finally, to make things worse, your traditional AppSec controls, so think about static analysis, dynamic analysis, they're not really well suited to find issues with open source components. So let's take a step back, right? So think about it. You have an area of, or actually open source components. You have vulnerabilities getting pushed into production real quickly. They stay there longer, and none of your traditional controls are able to catch it, right? So I don't know about you guys, but to us, it sounded like something that we had to look into.
And obviously, as a SaaS company, it wasn't just our interest in the security of our application based on these open source libraries. It was also our customers that were coming to us as these vulnerabilities were hitting headlines about, hey, are you using this version of that library and are we vulnerable? And what are you doing to fix that? So we had to come up with some solution to be able to answer those questions quickly as well as get a better control of our own security posture. So kind of what we started with was we have our code up in a repo such as GitHub. So we put a server in place that we could go ahead and clone those repos down and do scans of them to see what sort of libraries we have. Patching that up into a portal to publish results from these scans that we could go in as security, view the results of the scans, triage the findings that were there, and then report to the engineering teams what they had to fix. And then as far as how we were going to get all this in a real-time, fast fashion was tying this in with a webhook so that as our developers pushed code up into the repo and that got merged into master, that would trigger a scan directly on our box and go through this whole process, trigger that scan, publish the results up. And this seemed like a really good idea on paper, but when we actually put this into practice, it was horrible. We had a number of problems. One, the server that we stood up to clone all these repos down and scan them couldn't adequately build all of the different projects that we had, and there were a lot of them. So we were getting basically very inconsistent results. The scans would go through, some of them would build and get uploaded to the portal, but a lot of them we noticed were missing. Not only that, but the scans that were completing and being published to the portal had a lot of libraries that ended up, once we went in, looked at them, talked to the engineers about them, well, these are dev dependencies. They're nothing that ever hits production. It's not something that we need to be as concerned about. Where are all our runtime libraries? And we weren't seeing those. Additionally, as our engineering team grew, this just wasn't going to scale. Having essentially 1 or 2 people on our ProdSec team looking at this portal and trying to manage all this stuff just wasn't going to last in the long run. So we went over to legal and said, okay, well, you guys also care about libraries. What are you using to keep track of what licenses we have? And they use this amazing tech called spreadsheets that they would send around to the engineering teams and say, hey, can you go ahead and manually fill this out with all the libraries you're using, what the versions are, whether deployed, with a myriad of other questions. And you can imagine how well that worked out. None of this was going to work, and we needed to do something different.
So as we started realizing that our initial approach wasn't working, we had to do something different. We had to build for scale. But before we went too far down the path of a new technology or process solution, we want to take a step back and define some guiding principles of what would drive our next version of this, right? So we came up with 3 principles. The first one was we had to put our bots to work. We had to integrate in the workflows that a developer normally goes through. We had to make security front and center with the tools, what they actually use on a day-to-day basis, right? We had to make sure that the developers get communicated the results from this testing, this tool, in exactly the same way as how they would get results from any other test case, whether it's quality or performance. Security has to be exactly communicated in the same way. That was one of our first principles. The second one was we wanted to make sure we build guardrails around the existing roads that developer takes. And guardrails meaning a security guardrail. What this means is when a developer wants to push code to production, security has to be built into the normal path that they would take to do that. They do not, or they should not have to go through something completely different process to get a security approval, right? This has to be built into the normal workflow. And finally, we wanted to make sure that our strategic toll booths, different companies operate at different cultures. We wanted to make sure that there is, at any given point of time, there is always an absolute minimum baseline that is always met. So if there's a developer who, in a rare scenario, is not meeting a minimum baseline, we will break the build in the build systems. It doesn't happen very often, but that's the expectation. And the third principle is going beyond awareness and focusing on developer inclusion. By awareness, typically it means that the developers are aware of what tools you're using, expectations from them, and they get communicated the findings, right? We want to go beyond that. We included our developers in the actual process of deploying the system, building the process. They have access to the same tools that we have access to. They have the authority to make decisions, and they are included in the overall process end to end. So they feel included and as an active stakeholder, not just a passive audience in this entire process.
So as we started working through these principles and how we were going to apply them, it resulted in a natural to use the popular buzz phrase, shift further left in our process. So again, to recap where we started, we were doing our cloning and scanning at the point of merge, which usually meant that anything that we did find, by the time we brought it to the developer's attention so that they could address it, it had already been deployed. Our new process of trying to put gates in focused more on the build server, which had the added benefit of actually having an environment that we could build everything in. We could go ahead and establish our strategic gates there and address any issues before we get merged to master, before we deploy. Additionally, giving the ability for our developers on their local workstations to do scanning on their own, for one, enabled us to get more accurate scan results, and two, helped empower them and get them as part of this process. So when we were trying to figure out where exactly to do all this and how to do it, we put a team together to figure out when we were going to actually go ahead and trigger. This was teaming up with our build and test engineers, as well as some representatives from the development engineering organizations working with the security team. And they brought us a number of questions. Build and test wanted to know what the resource load is. If we're doing scans all the time on our build server, how is that going to impact the regular build process and the pipelines that we have going through there? The dev teams were obviously interested in how much time this is adding to their build. So we had to look at these things, and in some cases it was very minimal. In some cases it was not, like upwards of 15 to 30 minutes for a scan to complete with a pretty heavy load. So this involved a lot of working with the teams to figure out how to reduce these numbers to get it down to something reasonable that everybody would be happy with. Which brought us to how much scanning is too much. Obviously, if we're just doing scans every time code changes, that's probably too often. What we really care about is when new libraries are added, not necessarily when you change a line of code. But we needed to make sure that we were capturing a minimum number of scans so that we could actually see what was going on, what libraries were being introduced, what vulnerabilities were there, and to make sure we caught them in time. And another concern we had with our engineers, or concern that they had, was making sure that we're preventing new issues but not punishing for legacy. And I'll get to what I mean there. Our number one goal here is that we wanted to stop the bleeding, right? Prevent new vulnerable libraries from being introduced into our code base and put out there in our application. And accomplishing that through the breaking of builds on our build server. But we don't want to hold our developers for ransom for legacy. And what we mean by this is if we have a developer who goes in to add a new feature and they might add some benign library or make no change at all, we don't want to have their feature prevented from going forward in the build by breaking it because of some library that a whole different engineer that may not even be there anymore had put in 2 years ago. It just wasn't considered right to make it that developer's responsibility to fix it before their feature could go in. We accomplish this through the use of a high watermark. So when we go through and onboard a team to this new process, we do a baseline scan. We capture a list of all the libraries they're using, vulnerable or not, and put that into a baseline file. When they go in and do a subsequent scan, we compare the new list of libraries and vulnerabilities to what was already there in that baseline. If the new libraries are all clean, we update the baseline and let them go on their way. But if we notice any new libraries, particularly with high vulnerabilities, we break the build at that point because we know that that developer that's putting out that feature is the one who introduced that vulnerable library. Obviously, this leaves a hole. What about that legacy debt? Those libraries that are already there that already have vulnerabilities, because not breaking the build for those effectively hides that, and that's not something we can deal with. Because from an attacker's perspective or from our customer's perspective, it doesn't matter whether that library was introduced this morning or 2 years ago. An old library with known vulnerabilities out there is going to equal well-known developed exploits that we're going to see being targeted across everything out there on the internet. So we accomplish this by leveraging our security champions. We have security champions embedded with all of our engineering teams, and we leverage them to triage this debt. We give them the view of the portal, the same view that we have of all the existing libraries and vulnerabilities, and basically put the onus on them to triage that debt, look at those libraries, see which ones have vulnerabilities that are actually affecting them, and upgrade them as appropriate. But still, the product security team will go through and review this, act as oversight for those security champions, as well as a resource to assist them in any sort of remediation guidance, or to go ahead and file vulnerabilities for any libraries that we see slipping through the cracks that they're not addressing. So this sort of brings us to where we are today. So what we've established is in our portal, we have 2 different workspaces for every development team that we have. There's a master workspace that houses sort of the official view of their code bases, and then a dev workspace where they can work on whether it's just trying to see some new libraries or trying to introduce for a feature, proof of concept, etc. Key to this is the dev workspace local scanning. And I want to sit on this point for a little bit because this was highly important for the success of this project. We have a lot of different build systems out there. We're primarily a Java and Node shop, but we have a lot of different build engines, a lot of different package managers that we're dealing with that contributed to a lot of our failure in the beginning of trying to get successful builds between Gradle and Maven, Yarn, NPM, getting accurate scans that we were confident in the results, that we were seeing the applicable libraries, the runtime libraries, and that we were seeing all of them. What was vitally important to that was getting our developers scanning on their local machines and working with them to ensure that the scans were accurate in what they would expect to see as far as their libraries. We have a scan script that we developed that runs through and allows them to use specific switches based on what build managers they're using, or build engines, package managers they're using. And once we tune that and get a successful scan, we have a mirror effectively of that script that we embed inside their Jenkins file on the build server so that the scans that we're getting on the build server are identical to the scans that they've already vetted on their local workstations. Additionally, we've opened up this portal across the organization. Our engineers are obviously able to go in there, look at the results of their own projects to see where they're at. Our architects can get a view over there, more of a holistic view across the portfolio of what libraries are being used and by what teams. Security, we can obviously go in there to get a view of what the vulnerabilities are in that landscape and file any vulns. But legal also has view into this same dashboard so they can get an idea of what licenses are being used by all the libraries in the system. To do a little recap here by the numbers though, of what we were actually seeing. On our first solution, about 90% of the vulnerabilities that we filed based on those initial scans we were seeing were determined to be irrelevant. What I mean by this is that the repos that we were targeting, because we were hitting everything in GitHub, we would come back from the engineers with answers like, well, this is deprecated. Well, this was just a POC. This isn't anything that's production. Or again, the libraries that we're filing these against are dev libraries. They're not anything that's actually deployed with the application. Over half of the repositories that we were cloning out of our GitHub and scanning were failing to build, so we were getting absolutely no visibility into those. And pretty much none of the vulnerable libraries that we caught through this process were ever addressed prior to being deployed. In our new system, we have complete coverage of runtime libraries that we verified, again, with every development team that we onboarded. We have 100% successful build and scan of every team onboarded. This was not an overnight success. It took us a while to get there, but working with those teams was vital to the success of that. And now 63% of all resolved vulnerabilities that we've identified were caught prior to merging into master, and that prevented those vulnerabilities from ever ending up in our live application. And then just pointing out that we onboarded 33 projects from 16 engineering teams within 1 quarter. And this was without bringing on any sort of outside consultant or hiring any additional people. This was less than 1 full-time employee just taking this on as a project. A lot of the work was being done by our security champions embedded in those teams, which also gave them buy-in to the whole process and helped this whole thing move to a successful conclusion.
All right, so we talked about a lot of different things, but before you leave this room, I have 5 key takeaways for all of you. The first one is security of open source components or the risks being introduced by third-party libraries is important. You should look into it if you haven't already. And it can, at the minimum, investigate what does it mean for your service, for your application. Secondly, it's relatively easy these days. There are tools and systems available that you can readily use to understand the implications, to understand your exposure. But do not do that in a silo. You have to collaborate with your engineering teams to really get the right visibility. There's just way too much risk of spending effort in non-valuable things if you do it as a security team in a silo. Collaborate with your engineers. Integrate in the CI pipelines. I cannot stress this enough. We are able to reach at a point within this initiative because we really integrated in our CI pipelines. It's extremely important. It's very important to get real-time feedback in the hands of the developers as early as possible. Don't penalize the teams. If you're integrating in CI pipelines, don't penalize them for legacy things that are already there. I'm not saying don't do anything about it. You have to address them separately outside of the CI pipelines. They are important, but not for the CI pipelines. And finally, enable and empower your developers. You really can scale only if you enable your developers or engineers. And with this authority, make them accountable for the decisions they're making. So to wrap up, we'll go for some questions, but in case you don't get a chance, feel free to email us here. We are reachable.